Hi, in this video we will learn small pieces and small facts and properties about sigma notation that will help us later to work with this notation in a better way. First, we will do some remarks. The first one is that, the summing notation, the summing variable that we have, which is like sigma I going from m to n. This I, we called it summing variable, is a dummy variable. What does it mean? It means that it by itself has no meaning, and you can replace it by any other variable you like. So you can use a k going from m to n, or a l going m to n. There's only one thing that you have to be careful. If the starting and end points have some variable like mn in them, you cannot use those ones as summing variables. So you cannot use something like n sum of n going from m to n. This is not allowed. This doesn't make sense. But other than that, anything you like, box starts from m to n, goes up one by one. That's the work. The second remark is that the starting point here, you see the summation. This is the starting. It can be 1, 2, 10, negative 5, anything you like. The starting point of the sigma notation can always be changed to 1. So this means what? When you have I going from m to n, I can rewrite this guy as sigma of a j going from 1 to somewhere. What is that somewhere? So here we have to be careful a little bit. So here, I made a small mistake here. I can write this as some j starting from 1 to somewhere of some sequence. The relation between the sequences is this way, that you have, first of all, j, if change starting point from m to 1, then the end point you need to change it to n minus the starting point plus 1, and the I here, you see, you have to change it to j plus m minus 1. So this will be j plus m minus 1. So this is basically happening by changing I to a new summing variable j, which they have a relation. It will be like this. J is I minus m plus 1. And then, if I is m, you see from here, you right away see if I is m, then j is going to be m minus m, 0 plus 1 is 1. And when I is n, then j is going to be I is n minus m plus 1. This is what you see at the end. So the starting point changes to starting point, end point changes to end point. And all the way out, everywhere you see I, You see, just solve this for I, this guy for I, it will be j plus m minus 1. And that's where this j minus m minus 1 coming. This will be important when we specifically learn some summation formulas. Let's do some examples here. Okay, so we have some sigma notations and we want to turn them to a new sigma which starts from 1. Remember what you do. Change this guy to something that starts from 1. So to start from 1, you have I minus 3 plus 1. In other words, I minus 2. If you subtract this guy, so and let me write it again. So j, if I do this one, as a result, when I is 3, it will imply that j is 1. So that's where j is 1 coming from. And when I is 20, it will imply that j is 20 minus 2 is 18. So that's the end point. And instead of I, from here you see, instead of I, we need to write j plus 2. So this will be j plus 2 to the power 2. So I turn this guy to this. And as you know, as before, I can, again, this is now a dummy variable. I can use I for that again. And this will be I plus 2 to the power 2. So that j is now a dummy variable and I change it to anything I like. In this case, also I have 3. Well, the same story will go again. So we will put j to be I minus 3 plus 1. Or in other words, j is going to be I minus 2. This will imply that when I is 3, then j is going to be 1. So this, I need to change 3 things. This one, and this one inside, yes? Here, this will be j equal to 1. When I is 27, then j is going to be 27 minus 2, 25. And wherever you see I, replace it by j plus 2. So this will be 2 times j plus 2 plus 1. And this is square root of 2j plus 4 plus 1, which is this guy. So you have to be careful that saying these things. Well, I can change again back to I by doing this. This remark doesn't mean that I can just take any m here and put 1. No, it needs to, you need to do 3 changes. The starting, the end, the variable itself. These 3 things, as you see I'm doing here. And well, for this one, j, we want to be from 1, so it will be I minus the starting point m plus 1. So in other words, j is I minus 4. From this, you see if I is 5, it will imply that j is 5 minus 4 is 1. If I is n, then j is going to be n minus 4. So then the summations here will be j going from 1 to n minus 4. And from here you see that everywhere you see I, you can replace it by j plus 4. So this will be 2 to the power I is j plus 4 minus 3. Let me push this a little bit further. And then sign of, for I, you put j plus 4 over n. See, this n and that and these are constant. Those are not the summing variables. So you can have those ones as you see. Let me rewrite this one, j going from 1 to n minus 4, 2 to the power j plus 1, sine of j plus 4 over n. So that's another thing about the sigma notation. This last thing, let me just write two properties, which is obvious to see, properties of a sigma notation. So if you have a sum of a constant multiplied I going from m to n, this you can take out that constant. C is a constant. You can take out that and just add from m to n AIs. And if you have AI plus BI, I going from m to n, you can separate this thing as write sum of AIs and then sum of BIs. So you have two sigmas rather than one. We'll see that these two properties, which is very obvious by the definition of sigma notation, are going to be very useful when we are evaluating some sums written in sigma notation.